All right, guys, in this video, we're going to be doing some practice problems for Chapter 10, Section 1, which is all about area of rectangles, parallelograms, and triangles. Okay, so first things first, we're going to be finding the areas of some rectangles and parallelograms. The formula here is the same for both. So we're actually going to be doing base times height. In this first problem, we have a parallelogram. You notice it's kind of like a tilted over rectangle, where the base is 7.7 meters and the height is 2 meters. So we're going to be doing 7.7 times the height, which was 2. And if we multiply that out, so 7 times 2 is 14, 0.7 times 2 is 1.4, so that's actually going to give us, let's see, 14 plus 1.4, which gives us 15.4, and that's going to be meters squared since we multiplied meters by meters. So our answer here is 15.4 meters squared. In the next problem, this is number 2. Area again equals base times height. In this case, base is 1 and height is also 1. So we've got 1 times 1, which is of course 1. Let's think about units. We've got inches times inches, so that's inches squared. So we have 1 square inch for our answer for number 2. In number 3, we have again base times height, so that's going to be 6.9 times 2.4. And we probably want a calculator for this one, but when we multiply those out, that's actually going to give us 16.56. And again, that's going to be inches squared since we multiplied inches by inches. So our answer here is 16.56 inches squared. In our last question, area again equals base times height. Our base here is 6. Our height here is 8. Remember, those are interchangeable. So if you wanted to call the base 8 and the height 6, that would totally work. But the way I'm doing it, we've got 6 times 8, and that multiplied together is going to give us 48, and the units are square inches again because we have inches times inches. So our area for that last one, 48 inches squared. All right, let's look at some areas of triangles. All right, guys, so here we're going to be looking at the area of some triangles. So our formula here is actually circled in green at the top. In this case, it's 1/2 base times height. Remember, we've talked about before the idea that every triangle is kind of like a half of a rectangle. So we can use this formula that's basically just a modification of the rectangle formula, 1/2 base times height. Okay, so in this first triangle, let's call our base this 8 miles. Now let's call our height this 4.5 miles. So what we're doing is we're multiplying 1/2 by 8 miles and multiplying that by 4.5 miles. Now, if we start doing some of the multiplication on this, 1/2 times 8 is 4 miles. And of course, the 4.5 miles gets left alone. So we got 4.5. That should be miles. All right. 4 times 4.5. Well, let's see. 2 times 4.5 gives us 9, and another 2 times 4.5 actually gives us 18. And when we think about the units, we have miles times miles, so that's miles squared. So our final answer here is 18 miles squared for that triangle. Next one up on the bottom here, we'll move to number 3 next. I'm going out of order, I know. We're going to have 1/2 base times height. So our base here would be 4. And our height here would be 1.5 inches. Oh, sorry, this should be 4 inches and 1.5 inches. In this case, I'm going to be flexible. I'm going to multiply the 4 inches by the 1.5 inches right off the bat. So this is going to give me 1/2 times 4 times 1.5 is 4 plus 2, which is 6. Factor in my units, 6 inches squared. So now I've got 1/2 times 6 inches squared, which is 3 inches squared. And there is my answer for that one. I'm now going to move to number 2. So here I've got 1/2 times base, which is going to be 5 kilometers, times height, which is going to be 1.9 kilometers. Okay. This one's going to be a little trickier because we have a decimal in here, but that's just fine. We'll just probably have to use a calculator at some point. So The first thing I'd really like to do is, again, multiply this base times this height. So I've got 5 times 1.9. Now, every time we multiply 5 by 1.9, it's like we're multiplying 5 by 2, except it's 0.1 less for each time. So when we multiply 5 by 1.9, we basically have 10, which is 5 times 2, minus 5 times 0.1, which is 0.5. So what we're left with is 9.5 for this multiplication, and that's kilometers squared. Okay, now unfortunately we have to divide this thing by 2, which isn't going to be super pretty, but if you divide $9.50 in half, what you wind up with is $4.50 as half of the 9, plus 25 cents as half of the 50 cents, so we wind up with 4.75 kilometers squared, and that's our answer for the area of that triangle. Let's look at number 4. So here we have, this is a weirdly set up triangle, but I'm going to call this 3 meters the base, and I'm going to call this 2.8 meters the height. Notice that in this case, the height, the altitude, actually falls outside the triangle, which is a little weird, but nothing we can't handle. Again, we're going to be using our 1/2 base times height formula. So that's 1/2 times 3 times 2.8. And this is going to actually give us units. I'm just going to write them off right away as kilometers squared. Okay. Now, in this case, I think the easiest thing to do is actually probably to multiply the 1/2 by the 2.8 right off the bat, because 2.8 is divisible by 2. So what we're going to wind up with is 3 times 1/2 times 2.8 is 1.4. And that's easy enough to multiply. 3 times 1 is 3, and 3 times 0.4 gives us 1.2. If we add those together, that's going to give us 4.2 kilometers squared as our final answer. So I solved those in a couple different ways. I hope at least one of those resonated with you. But guys, there's a couple options to tackle the area of a triangle. So that's the whole of 10.1. And next time we're going to come back and practice areas of trapezoids, areas of rhombi, areas of kites, which are 2 formulas that we'll cover next time.